Hey, welcome back. This is Mr. Riley with our next topic in our unit on linear functions and linear relationships. And this will actually be our last topic, which is constant rate of change and slope. So we start on page 396. This one's going to bounce around a little bit. Constant rate of change and slope. So we'll start with talking about rate of change. So the rate of change is how one quantity changes in relation to another. Okay, so we've been looking at input and output quantities, right? So when the input quantity changes, the output quantity changes. So those are the two things that we're talking about. And the rate of change is the ratio of how those two things change together. And in a linear relationship, that rate of change is constant. And so it's called a constant rate of change. A linear relationship is one where if you graph the x and y values that go together, the graph turns out to be a straight line. And that straight line will show a constant rate of change. And that's what we're going to talk about today. A couple of different situations, one with a table of values, then we'll talk about graphs in a little bit. So we start with example one here. So this table shows how much distance you've traveled on a zip line, right? So time in seconds, so how long you've been traveling, and then what the distance is along the zip line. And they give you a bunch of values in this table. So after 2 seconds, you went 12 feet. After 4 seconds, 24 feet. And you'll see these numbers on the top here, which is the change from one entry in the table to the next. So when the time goes up by 2 seconds here, the distance traveled goes up by 12 feet. And when the time goes up by 2 seconds again, the distance traveled goes up by 12 feet, and so on through the table. And all these intervals happen to be the same. We'll talk about that here in a minute. So what we're talking about here is the change in x and the change in y. The red plus 2s are the change in x. The blue plus 12s are the change in y. And the rate of change is always the change in y, the change in output value, divided by the change in the x, or the input value. And we can shorthand that. We've talked about this before using this notation, the Greek letter D, delta y over delta x, the change in y divided by the change in x. That's how you read this, okay? And the book goes on to say, okay, so every time the change in y was 12 and the change in x is 2, so the rate of change is constant, 12 divided by 2, which you can simplify. And we do this as a unit rate in real world problems. So you just do 12 divided by 2, and that's 6 feet per second. So the rate, how fast this person or the zip line is moving, is 6 feet per second. So 6 feet per second is your answer. That's the constant rate of change for this table. All right, so what I don't like about the book, and the 7th grade book and the 8th grade book, they're all like this, is when they do these tables of values, they have all the intervals being the same. 2, 4, 6, 8, 10, 12 are the values of x here. And so what happens is these numbers, the change in x always ends up being the same number. This is not what's important, that all these changes in x's and all the changes in y's are the same number. What is important, what makes it a constant rate of change, is that the ratio of the change in y divided by the change in x is always constant. Not that the two numbers are the same, but that their ratio is the same. So it's very simple when their tables are set up like this. But if you look at this second example, which I have to make up because the book doesn't do this, the change in x is different intervals, right? So at 4 minutes, you were at 160 feet, and at 5 minutes, you were at 140 feet. Then at 8 minutes, 80 feet. Okay, so it's not so obvious here that these are not all going to be the same. The change in x you get by subtracting the new x minus the old one, right? The difference from 4 to 5 is plus 1. So the x goes up by 1. And then the next interval here, the x goes up by 3. And then in the final one, the x goes up by 2. So the fact that these numbers are different doesn't mean anything. That just is because of what values are in the table. The y values that go with these, from 160 to 140, the y goes down by 20. From 140 to 180, the y goes down by 60. And then the altitude in the last step here of the table goes down by 40. So these numbers are all different also. But what you have to do here, which the book is not good about, what you have to do is show the change in y divided by the change in x. Negative 20 over 1, that equals negative 20. Negative 60 over 3, it went down 60 feet over 3 minutes. That's also negative 20. And negative 40 feet over 2 minutes is negative 20. This is your constant rate of change. Doesn't matter that these delta x's and delta y's are different. It's the fact that the ratios are all the same. And so the constant rate of change here, this is like an airplane coming down for a landing or something, is negative 20 feet per minute. Negative 20 feet per minute is the rate of change. Don't look at the pattern. Look at the change in y, the ratio of the change in y divided by the change in x. One more example here to kind of hit this home. The number of transactions happening in a bank account and the bank balance is what's happening here. So the transactions goes up by 3, okay? And if you can't do these in your head, you're really just subtracting the new value minus the old, okay? Then the transitions goes up by 6, from 6 to 12, okay? The change in the balance from 170 to 140 is minus 30, right? That's 140 minus 170. And 80 minus 140, the change here is minus 60. Okay, so again, if these numbers happen to be too complicated, you can't do them in your head, you can use a calculator or write out it's a subtraction. The change, the difference in the y values is a subtraction. Okay, so then you look at the ratio. Change in y divided by change in x. Negative $30 over 3 transactions is negative 10. Negative $60 over 6 transactions is negative 10. There's your constant rate of change, negative $10 per transaction. The ratio is where your answer is. Okay? All right, so here's a couple for you to try on your own. Number 4, number of items being purchased and the cost associated with them. What is the rate of change? So our change in x here, the number of items goes up by 10, then it goes up by 5. The cost going with it goes up by 24, from 12 to 36, and then it goes up by 12. So the rate of change, the ratio, change in y divided by change in x, is 24 over 10, or 2.4. And then in this step, it's 12 over 5, which is also 2.4. So this is your rate of change, 2.4, real world problem. We're going to express that as a unit rate. And so the answer is $2.40 per item. Number 5, the amount of money in an account and the number of days. So the number of days goes up by 3 and then goes up by 2. The change in money goes down by 45, 35 minus 80, negative 45, and then goes down by 30. So your rate of change is negative 45 over 3, that's negative 15, and negative 30 divided by 2 is also negative 15. So your rate of change is negative 15, negative $15 per day, negative $15 per day. I did not put in the delta X and delta Y labels here on these tables, nor did I label them X and Y, which I didn't really talk about, but you do have to decide which is your input value and which is your output value. Should be obvious most of the time, but all right. So we're going to step away from real world problems for a second. Rate of change is a real world problem thing. Okay, so now we're going to look at a concept that is also used quite a bit here with, in graphs and in X and Y coordinate things, and that is slope. Okay, so when you think of the word slope in the real world, it means sort of a hill or a slanted, platform or something like that. The truck drives up a slope. You ski down a ski slope, okay, or a ramp is a slope. A set of stairs is very commonly used when you talk about slope. We'll talk about that in a second. So this is the word slope in the real world. In math, slope describes the steepness of the line if it is graphed. Okay, it is the ratio of how the rise or the vertical change between 2 points on the graph divided by the horizontal change. Okay, so vertical change divided by horizontal change. It is frequently said rise over run. The change in y value from 2 points, right? That's the vertical distance between 2 points on the line, is the rise, and the horizontal distance between 2 points on the line is the run. Okay, so the change in y is the rise, and the change in x is the run. This might look very familiar to rate of change, which we'll get to here in a minute. Slope is rise over run. Okay, and there's two basic ways to calculate slope. The first one is when you are given a graph by counting the blocks of rise and the blocks of run. Okay, so we draw what's called a slope triangle. Okay, the vertical distance between the 2 points and the horizontal distance between the 2 points, and we measure those lengths. We just count the blocks. So in this first one, line L here, the run between these 2 points, okay, just going horizontally until I get right underneath the second point here, is 1. And the rise between these 2 points is 3. So the slope of this line is a rise of 3 divided by a run of 1, 3 over 1, which we simplify to just 3. So a whole number for slope means that the run is 1. This line, not as steep as the first one, as line L. The rise in this one is 1, and the run is 3. So the slope of this line is 1 over 3, and that's the answer, 1/3. We leave slopes as a fraction, even if it's an improper fraction, because it's the rise over the run. So that's pretty common for non-real world problems. Okay, here's a couple more examples. When you draw in your slope triangle, move from right to left. Okay, so you start with the point that's furthest to the left on your line, a point. Pick any point, right, where it goes right through the crosshairs of your graph paper. And from there, you can go up to the vertical height of the second point that you're going to choose. Okay, so in this case, up 3 units, and then go straight across horizontally till you get to the point and measure the horizontal distance, the run, which in this case is 4 units, right? Each block on the graph is a unit. And so the slope of this line is 3 over 4, positive 3 over 4. This line's going up from left to right, which of course implies that what happens when it is going down from left to right, and that is going to have a negative slope. So slope can be positive or negative. We always look at the line going from left to right. If it's going up from left to right, it's a positive slope. If it's going down from left to right, it's a negative slope. So to find the slope of this red line, we start on the point on the left, and we go down now until we get to the vertical position of the second point. That's 2 blocks down, and then we go to the right 4 blocks in the positive x direction, a run of 4, and so the slope here is negative 2 over 4. Negative 2 over 4, which simplifies to negative 1/2. So we simplify the fraction, but again, you can leave it as an improper fraction if it is not a real-world problem. All right, so 2 examples for you. What is the slope of this line? So you pick any 2 points. I'll pick 2 that are not right next to each other for this example. So I go across, and then I go up to this point if I chose these 2 points to get my triangle. Okay, so my run here is 3, and my rise is 1, 2, 3, 4, 5, 6, 7, 8, 9. And so the rise over run is 9 over 3. 9 over 3, which simplifies to 3 over 1, or just 3. Just 3. So the slope of this line is 3. Positive because it is going up from left to right. If you leave it as 3 over 1, that's okay. It's sort of not a simplified fraction if you leave it as 3 over 1. So normally you would see this, like certainly in a worksheet where you're given answers, you're never going to see 3 over 1 as the answer. It'll always be written as 3. Okay, how about this one? Okay, so this is the work that you should show, right? Draw in your slope triangle and show the counting of the blocks. And your difference vertically here, the rise is -3, the run is 4. This line is going down from left to right, so it has a negative slope, -3 over 4. And the minus sign could go in the front, of course. Okay, so that's finding the slope by counting blocks. And when you do this, again, the work you should show, draw in your slope triangle, write in the lengths of the 2 legs. If you chose this point down here, right, then you would have 6 and 8 as your rise and run. When you simplify, you get the same answer. So it doesn't matter which 2 points you pick on the line, as long as they're right where the crosshairs of the graph paper are, so you can count full blocks. All right, well, what if you don't have a graph? That's the second method for calculating slope, and we can do that by using the slope formula. So on the graph, if you think about the graph, the 2 points that you have each have x and y coordinates. We call them x1, y1 for the x and y coordinates of point 1, and x2, y2 for the x and y coordinates of point 2. And if you think about what happens here, when you subtract the y coordinates, that gives you the difference vertically between the 2 points. That's the rise. And if you subtract the 2 x coordinates, that gives you the run. So the slope formula is M. M stands for slope. Don't ask why. You can Google it and see what you come up with. But M is just used for slope. Okay. Slope is the difference in y coordinates. That's the rise. Y2 minus y1 divided by x2 minus x1, the difference in the x coordinates. These little numbers underneath here are called subscripts. I don't know if we've talked about them before. They're used to specify a specific value of the variable. Okay, so y sub 2, y subscript 2, which we just say y2, means a specific value of y. It's the y value for point 2 on your graph. x2 is the x coordinate of point 2. Okay. So don't get confused with those, not like exponents or multiplication. They're just specific labels, okay? And it says here in the book here, which is important also, that any 2 points can be chosen as x1, y1, and x2, y2. You can switch the order of them. You just have to make sure that the first one you use for y is the coordinate of the same point as the first one you use for x, right? If you mix those up, then your answer will be the opposite of the actual answer, okay? All right, so here's how you use the slope formula. You get asked the question like, what is the slope of the line that passes through these 2 points? So given coordinates of 2 points. One of these points we'll call point 1 and one we'll call point 2. So sometimes it's useful, especially in the beginning, to label those. 1, 2 are the x and y coordinates of point 1. So that's x1 and y1. And 3 and 5 are the x and y coordinates of point 2. That's x2 and y2. Okay, so we label these. Now we can just substitute these values into the formula. The slope formula is y2 minus y1. So that's going to be 5 minus 2 divided by x2 minus x1, which is 3 minus 1. And then you just do these subtractions. Be careful with positive and negative number subtractions because you'll see those in these kinds of problems. 5 minus 2 is 3. 3 minus 1 is 2. So the slope of this line is 3 over 2. You don't have to graph the line or count blocks. You just use the coordinates to find the slope. So in the book here, they combined all of these together and just talk about finding the slope of a line. And they don't really tell you which way to go. In the examples on page 398, they show the graph and they use the slope formula. Okay, well, you can really do either one. You don't have to do both. If you're given the graph, it's typically easier to just draw in the slope triangle and count the blocks. Right, the slope of this line is positive 3 over 4. the slope of this line, -2/3, -4/6, which simplifies to -2/3. If you use the slope formula for these two problems, right, then you write in your y2 minus y1, x2 minus x1, and you then do the subtractions and simplify if you have to. Okay, so what work do you have to show for these problems? If you're counting blocks, you draw the slope triangle and draw it right in your lengths for the rise and the run, and then your answer. If it's not simplified, right, then you write your original ratio and then the simplified answer, typically. If you're doing the slope formula, I do not require you to write the slope formula. You don't have to write m equals y2 minus y1 over x2 minus x1. Okay, but what you do have to do is write in the substitutions of y2, y1, x2, and x1. That way, if you make a mistake, you have one backwards, it's obvious what you did wrong. Okay, or if you do an arithmetic mistake in subtracting or something like that. So you must write this step that I have circled here, the substitution into the slope formula. And again, be careful. You get, negative coordinates frequently. And so 2 minus -2, that's +4, right? 2 minus -2 is the same as 2 plus 2. Just be careful with your integer adding and subtracting rules. All right, so here are 4 problems for you to do on page 398, which I have printed out for you on your notes page. The first 2 where they give you graphs, go ahead and do them by counting blocks, and the second 2 do by using the slope formula. So 3A, your rise and run here are 3 and 5. Positive slope. I always check the line and make sure my positive and negative is right. I don't really worry about whether these are positives or negatives when I draw in my triangle. I just look at the line. It's going up from left to right, so it's a positive slope, +5/3. Number 2, or 3B rather. You don't have to choose the points that they chose. You could just choose these 2 points because the line goes through here, right? Or you can go all the way down to here if you wanted to, right? That this is 4. Might want to write -4, but if you don't write -4, that's okay. Right? It's 4/2. It's negative. And so that means this line has a slope of -2. 3C, no graphing, just given two sets of x and y coordinates. Substitute into the slope formula. y2 minus y1 over x2 minus x1. That's -1/5, -1/5. And number 2, or 3D, 3 minus -5 for y2 minus y1. 8 minus 1, x2 minus x1. Gives you 8/7. And recognize if you did this the other way around, right? If you picked these numbers as your x2, y2, right? That you would end up with -5 minus 3 on the top. And on the bottom, you would have, you have to do 1, right? Because the 1 is what goes with the -5. So that's what you have to be careful about. So your x2 then would be 1 minus 8. And if you do this, you'll realize that you get -8/7, right? And so -8/7, that simplifies to +8/7. So it's the same answer no matter which point you choose as point 1 and which one you choose as point 2. Just have to make sure that they line up. The y and the x, the first ones you use have to be ones that go together, the -5 and the 1 in this case. Okay. All right. So that's slope by slope formula, slope by counting blocks. Now there are 2 special situations here. So we talked about positive slope and negative slope. Well, what about if the line is horizontal? Okay. It doesn't change. There's no rise. It just goes straight across, horizontal. Well, if you counted the rise of this, it would be 0, right? So the rise is 0. The run is, I don't know, infinite or any number. Okay, that's going to end up with 0 over a number which is 0. And if you go vertically, the vertical line has a rise of who knows, whatever number, and a run of 0. Okay, so I have a couple more example pictures here. So the horizontal line like this one, pick any 2 points on the line. They all have the same y coordinate. They're all a y coordinate of 3. So the rise is 3 minus 3, no matter what points you choose. And the run, who cares? It could be anything. But the numerator is 0, and 0 divided by anything is 0. So a horizontal line has a slope of 0. It does not have no slope. Don't say no slope. The slope is 0. A vertical line, the x coordinates are all the same on a vertical line. All of these points on this line have an x coordinate of 4. Okay, so it doesn't matter what I choose for y coordinates. It comes out to any number. The denominator, though, comes out to 0. And any number divided by 0 makes your calculator explode, right? You cannot divide by 0. So the slope of a vertical line is undefined because you can't divide by 0. The slope of a vertical line is undefined. That's the word we use. All right, so 2 problems for you to do. Again, from God, it's in the book here, page 399. No graph, so use the slope formula. For A, y2 minus y1, 7 minus 7 is 0. 5 minus negative 1 is 6. But 0 divided by anything is 0. Okay, and you might again recognize the y coordinates are the same. That means that this is a horizontal line. Horizontal line. And this one, you can guess here. y2 minus y1, negative 1 minus 4. x2 minus x1, 2 minus 2. The x coordinates are the same. Then you end up with a run of 0, where the change in x is 0. Can't do that in your calculator, so this slope is undefined. And this line, of course, is a vertical line. Okay, I didn't put this in here, but one way to help remember, 0 starts with a z, and 0 has 2 horizontal lines, a z, right? Z has 2 horizontal lines. And undefined starts with a u, and the u has 2 vertical lines. So you can see the vertical lines here of the u for undefined, horizontal lines here of the z for 0. One way to help you remember, because people get these confused. You don't see them too often in real world problems. But so back to the real world. Okay, so real world slope and rate of change are the same thing. They are exactly the same. They are synonyms. Okay, in the real world, we typically talk about rate of change, but you could use the word slope also. If you are given a graph in a real world problem, you can count blocks in the graph to find the slope. If you're told to find the rate of change, it's the same thing. You can count the blocks from a graph, or you can use the slope formula. Okay, so circle 1 here, they are talking about circular design. Find the constant rate of change of circle 1. That's this green line, right? So they pick 2 points on the line. You could count blocks here. It looks like it goes down a half of a block for 2 seconds. Or if you went from here to here, down 1 block for 4 seconds. Okay. Or you can use the slope formula like they showed you here, that you have pick 2 points, 2 seconds and 5 centimeters, and 6 seconds and 4 centimeters. That's what they did over here. And then they use the slope formula, and you get negative 0.25 centimeters per second. Now you might say negative 1 over 4, right? And you could leave it as a fraction, but typically in real world problems, like we talked about earlier, we express rate of change as a unit rate. So you would divide this and put your answer in as a decimal, okay? So negative, and because it's going down, right, the line's going down, negative 0.25 centimeters per second. All right, so what is the slope or rate of change of circle 2? What is the rate of change of circle 2? Not sure that I put a picture of circle 2 on the next page. So we'll take a quick picture here. And oh, did I not even ask that question? Oh, well, let's do that then. Okay, what is the rate of change or the slope? What is the rate of change of circle 2? If I'm given a graph like this, I would draw in my slope triangle. So that's 3. That's 2. So my rise and run are 3 over 2. We will not leave this as an improper fraction in a real world problem. Instead, we will divide and write the answer as a decimal. So 1.5 centimeters per second is your rate of change. It is positive, right? Because the radius is going up as the number of seconds goes up. All right, so this summary table on page 397 is a good one. Rate of change is positive if in real life the value is going up over time or changing with typically it's over time. In a graph, it'll be going up from left to right. Negative rate of change means that a value is going down as time goes on, okay, or the y value goes down as the x value goes up. A graph of that goes down from left to right, okay? And you could have, of course, 0 as a rate of change, which means the thing is not changing at all. Not a very interesting real-world problem, but 0 slope is a horizontal line, okay? And they don't talk about vertical because, again, most of the time these are things changing over time. And so something can't change over time instantly, right, to go from one value to the next without time moving on. So that's why you don't see the vertical line here in the real world situation. All right, so one last example here. What is the rate of change for this graph, which represents how much you pay for a taxi ride? Number of miles and the different amounts of money. So what is the rate of change? So you could use the graph, okay? We'll go over that at the end here. One thing you do not want to do is just count blocks here. So let's use the slope formula and pick 2 points, 2 x and y values that go together. Okay, so 0, 4, and 5, 8 would be fine, or you could pick other ones if you wanted to, but I chose 0, 4, 0, 4, and 5, 8. All right, so you substitute these into the slope formula. 8 minus 4 and 5 minus 0. So it's a change of 4 in y for a change in 5 of x, 4 over 5. Okay, that's your slope. If it was not a real world problem, you could just leave it as 4/5. But it is a real world problem. In fact, it's talking about money. So we certainly are going to go to decimals. 4 divided by 5 as a decimal. What is the rate of change? 0.8, right? Which is, we don't say $0.8. That's 80 cents. So the rate of change here is 80 cents per mile. Now, if you were to do this with counting blocks, just to point out to be careful here, if you counted blocks, you might be tempted to say that this is 1 over 2, okay, which is true. By blocks, it's 1 unit divided by 2 units. But the thing is, on this particular graph, each of these blocks is not worth 1. Each block here is not worth 1 mile, right? On the x-axis, each block is actually worth 2.5 miles. And on the y-axis, each block is worth $4. So you can't just count the blocks. Really, you have to look at the change in values, right? So from here to here, the y is actually going up $4, just like we did with the formula, okay? And the x is going up 5 miles, right? So you actually have to look at the scale in real-world problems if you are going to count blocks. You can do it, but you just have to be careful, okay? So we'll get some practice with some IXLs on this stuff, and we'll go over these more in our next class. Slope and rate of change, the change in y, or change in output, divided by change in input.